So binomials is the new thing for today, binomial probabilities. And what you've been doing up until now has been probabilities, but you might not think of them as probabilities. If I said there was 5 different kids and I was going to pick out groups of 2, you might be able to go, what's the probability that you're going to get picked out of those 5 kids if you're making groups of 2? Well, first, let's just do the 5C2, because if I'm just picking out 2 kids, there's no reason to think that that is order matters. This is 5C2. So would everybody please figure this one out? Calculators are allowed for these. And I would totally either do 5NCR2 or I'd do that little factorial thing. 5 factorial over something else. Give this one a shot. All right, Lydia, what do you think it is? 5 factorial over, what are the other factorials that are on the bottom?
Would it be the 2 and then 3?
Yep. Where'd you get the 3 from?
The 5 minus 2.
Yeah, that one minus that one, and it goes here. And then there's an extra one of these. Noah, 5 factorial is really 5 times 4 times 3 times 2 times 1. What's 3 factorial?
3 times 2 times 1.
And then 2 factorial.
2 times 1.
And then what cancels?
3 times 2 times 1.
Good. And then this is left with 5 times 4 over 2. 10 is correct. Raise your hand if you had 10 for your answer. Good. There's 10 different ways you could have groups of 2. But the more complicated question is, like, what's the probability that it'll be the group you want? Well, let's say there's 5 people, and let's say there was this other person that you were really interested in, and you were like, I hope that I get to be in the group with that person. Well, only one of the groups is exactly that group. It's a 1 in 10 chance that happens. See how it turns into a probability? You just take 1 out of that. Now, there's more complicated kind of scenarios, like, what's the probability that I am in one of the groups that gets picked? Well, then that's much more complicated. All right, so now let's talk probability. Imagine for a second you're at the end of a basketball game. If you've ever seen one, if the game is really close, they foul people a lot because they want to slow the game down and get it down to they want to have a chance that they can shoot some free throws at the end and win the game, okay? So let's say that there's this person who's like the star of the team, and they're a 95% free throw shooter. They're going to try to make that person have the ball at the end of the game, because if they're a 95% free throw shooter, they want them shooting the free throw. But what if they get 4 free throws at the end of the game? You can't really get 95% when you have 4 free throws. So what's the most likely number of free throws? Or another way to say it is, what's the probability that they will make at least 3 out of the 4 free throws? Well, I can say it's pretty high, but you can actually calculate it using this special formula called the binomial. All right, so everybody write this one out, 95%. Would you agree, if there's a 95% chance that the person's going to make it, then there's a 5% chance that they're going to miss it? Always put the 2 side by side. And I would always label one as make. Always, in probability, there's one thing you kind of want to happen. Maybe you were betting on the game the other direction and you wanted to miss. Okay, but anyway, one of them's got to be a positive and one's got to be a negative, like making it and missing it. Okay, then what you do at the beginning of this thing is you put a C thing, like combination. We just learned those yesterday. So if I said this person was going to take 4 shots, you put 4C. And how many of them do you want him to make? Well, if you're on his team, you want him to make all of them. So let's say, what's 4C4? This is how many total shots the person gets. This is how many they make. Then you're saying you want 4 95% and no 5% to happen. That's another way to think of that. And now that's all stuff that can go in a calculator and you can actually figure out the answer to it. I'll tell you exactly how we would do this. That, I would do it with 4 factorial over 4 minus 4 is 0 factorial with an extra one of these on the bottom, 4 factorial, and that's just 1. Well, that's easy. The first part is 1. The next part is 0.95 to the 4th. Do you know how to put that in a calculator? And somebody smart's going to be able to say why I don't even need to put in this end part. Yes?
Anything to the power of 0 is 1.
Yeah, that's just 1. So all you really have to do for this one is go 0.95 to the 4th. So grab your calculator and type in 0.95 power of 4. And you got it already, sir?
31.44%.
And there's this tension between, do I read off the decimal, 0.8145, or do I say the percentage, 81.45%? And I'm accepting either one of those two. Just be careful that you, if you do it this way, you say percent afterwards, just like you did. So that was perfect. So wait, there's only an 80% chance this kid's gonna make 4 out of 4? Well, think about it. There shouldn't be a 100% chance that they're gonna make 4 out of 4. Even though they're a really good free throw shooter, shouldn't be a 100% chance. But yet it should be pretty high. Well, that's how you figure them out. So I want to see if you can set these up. That's how many shots you get. That's how many you want them to make. This is also how many you want them to make. So this number just gets copied right there. And this is how many you want them to miss. All right, so now here's your new scenario. Let's say this is a high school level kid. And let's say that they're an 80% free throw shooter. Still pretty good. Let's say they get 3 shots at the end of the game. What's the probability that an 80% free throw shooter will make 2 out of 3? Starts with a C, and then it has 2% next to each other. Have I told you enough like this? I hope I have. In theory, you could do this, but I know this might be too hard for some of you right yet. Maybe you need a few more for practice. All right, there's a couple cell phones out on desk. If you could put those away, please. I know you're not using them right this second, or I'd be saying this in a much meaner way. All right, Taylor, can you tell me if this is 0.80, what's the other one?
3. 2 times 3.
Oh, that's this thing.
0.
If this is 80, what goes with it over here? Together, hint, they add up to the only 2 things that could happen. They make it or they miss it. 80% chance they make it, 20% that they miss it. Okay, good. Now, I said that this number would get copied right there because we have 2 makes. And if you have 2 makes, we must have 1 miss. How many of you set that up right? Raise your hand if you did. Woo, that's a lot. You guys caught on fast. This is good. Now can you put it in the calc? Or do some of it in your head? I personally would do that 3C2 in my head. But if you really like, you could go off in your calculator and go 3 NCR2, and you could do it that way. You know where that is on the math menu of the calculator? Math, probability, NCR. Stella, did you get 3C2 yet? All right, I'm going to do it by hand. I want you to help me. 3 factorial over 3 minus 2 is 1 factorial, and I'm not quite done. Do you know how to finish that? An extra 2 factorial. Good. That's really 3 times 2 times 1 over 1 times 2 times 1. What do you think the answer is? Yep, those cancel. The answer is 3. So this whole thing is just 3. So then I'd use my calculator. 3 times 0.8. Do you have to say 0.80? It's the same exact thing. Just skip the 0. to the second times 0.2 to the first. Don't have to even type to the first because that means the same thing as 0.2. And you'd have your answer. Parker, what did you get? Are you still typing it? Go ahead. I'll give you a second to finish that off. Can anybody verify 0.38? A bunch of people. All right. If you didn't, I really encourage you to go back and type this in again more carefully, exactly the way I have it, because otherwise you're typing it wrong. Now, I know some of you are like, 38% chance, that seems low. But the problem is that he's actually more likely to make 3 out of 3. Think about it. If he's an 80% free throw shooter, he should probably make all 3 of them. Okay, so 38% chance of this is only low because there's a high chance he's going to make 3 out of 3 of the shots. All right. Do you get there's a very low chance that the person would only make 1 of the 3 shots? They're pretty good. So they're not going to miss 2 of them. I mean, pressure gets to people sometimes, but... All right. Can you please make sure that you can get that to work? Because otherwise, if not, you're not doing it right. And if yours isn't coming up right, the way I would try to fix it is put in time signs and make sure you're using the parentheses if yours wasn't working before. If you put the parentheses in and you put time signs in between them, I guarantee you it's going to work. Another thing is sometimes people put more than just 2 as the power. By accident, they end up typing more in the power than they meant to, so let's make sure you can get 0.38. Okay. Kohler, tell me a sport that you like.
I run track.
All right, so in track. So let's say that 90% of the time, that you win your event, okay? If 90% of the time you win, then obviously 10% of the time you lose, right? Okay. Then what if you had 3 meets in a row, like 3 days in a row, you have a meet and then another meet and then another meet. What's the probability that she will win all 3 times? She normally has a 90% chance of winning. Now that's a little too boring. That you could do just by 0.9 times 0.9 times 0.9. That's a little too easy. So we're gonna do, what's the probability, given she wins 90% of her races, that she wins 2 out of 3? Let's see if you can set that up. It's got a C in front, something, see something, and then 2% to the right powers. See if you got this. Hatis, what C what? What goes here? What goes here? Yep, 3C2. And then, Marcella, these 2 parentheses?
0.90.
And?
Second and 0.10.
Perfect. Noah, can you tell me where this 2 has to be replicated? There's another spot.
Above the 90.
Yep. And then by logic, JP, what has to go here?
1.
Yep, because there was a 3 total chances. 2 plus 1 makes 3. And now, this looks very similar to one we did in the past. 3C2, 3 factorial over 3 minus 2 is 1 factorial with an extra 2 factorial. And that was 3. 3 times 0.9 to the second and times 0.1. And I don't need to say to the 1 because that's irrelevant. So then type that in. Eddie, what'd you get? Okay, go ahead and type that in. Humphreys, what'd you get? Okay, I'll pause for a second while we take the time to finish this problem.
0.24.
Eddie, can you verify that?
Yeah.
0.24 is correct. There's only a 24% chance that this kid is going to make 2 out of the 3. Why is that so low? Because they'd probably get 3 out of 3. And you can't get 3 out of 3 and 2 out of 3. It's got to be one or the other. It's more likely they'd get 3 out of 3. So now I want you to do the same problem, except let's prove what I just said. That their probability of getting 3 out of 3 must be higher than 24%. Everybody do the same exact problem, except 3 out of 3. You can shortcut that a lot and type it in really fast if you know what you're doing. 3 out of 3. So how did you know that it would go really fast? What made you realize that?
The 10th is just the 0, and 3 out of 3.
This is just to the 0 power, and that to the 3.
C3 is just 1.
And 3C3 is just 1.
0.9 to the third.
So it's really just 0.9 to the third. He's right. There's a 1 after you calculate it. If you didn't know 3C3 was 1, you'd get 1 there. And then this is 0.1 to the 0, and that's just 1. So it's really just that. And can you tell me what it is?
72.9%.
Do you see why there was only, I'm going to round that to 73%, that there was only a 24% chance you'd make 2 out of 3? Because she's probably going to make 3 out of 3. Why isn't that up to 100%? Yes.
Because there's also the possibility of 1 out of 3.
Also a chance of 1 out of 3. And also a chance you won't win any of the 3 races. So this one is the most likely. This one's second most likely. And then there's a very slim chance you win 1 out of 3. And almost 0, but not 0% chance of winning none of the races. Okay, I think you get it. Now here's where they get more complicated. This is like honors level. See if you can handle it. This kid, let's stick to the 90% because that's fairly easy. 90% chance of making his free throws, 10% chance he's missing them, so everybody can set that up. But here's the thing I could see a coach saying, okay, so do you guys know that you could end up with 3 free throws at the same time? In a game, they could say, you get to shoot 3 right now. Do you know why? Yes.
You get fouled past the 3-point line.
Yeah, you're shooting a 3-pointer, and they foul you. If the rule was that you could only have 2 shots, then everybody would always just hammer the person shooting the 3-pointer because they could know that the most they could ever get on free throws is 2. So they have to give them 3 shots to try to give them a chance of getting their 3 points. So if there's 3 shots, I could see the coach saying, well, what's the probability that at least the kid makes 2 out of the 3? And I said at least 2 out of 3. Well, first of all, you figure out 2 out of 3. And that'd be this one, as long as you can figure out what goes here and what goes here. And then, of course, there is the 3 out of 3 chance, which would look like this. As long as you know what this and this are. And if I say at least, then that means this or that. Do you get the coach must be happy if they make 2 or 3 of the free throws? Like, maybe they only need 2 points and then they'll win. And yay, if they get 3, cool. But we need at least 2, which means 2 or 3. So that could the most complicated thing they could ever do to you. And then you would have put this 2 up here. And if they make 2, they'd miss 1. And then if this 3 has to get copied up to there, if they make 3, then they're going to miss 0. And or means add. One of those things I want you to get used to in probability, if I say this or this, it's like we added them together. You'll see more about where that comes in. So you would get one answer for this. And another answer for this. And the probability of at least 2 out of 3 would be that or that. So you'd add those 2 together. And what did you get for a final answer? You got it, Eddie? Okay, did you get the top one or the bottom one, or are you just sitting there?
Just sitting there.
Okay, do the top one. Mr. Humphries, I'd like you to do the bottom one. The blue one. Whenever one of you guys is done, raise your hand and tell me what you got. Now, Mr. Humphries, there's a way you could have done yours faster, because that is just 1. And this is just 1. And it would have just been 0.9 to the third. So what'd you get?
72 or 73%.
0.73, okay. And Eddie, the top one? Yours is definitely longer than his was, so I'll give you some more time.
24.
Yep. Add them together. Raise your hand if you knew it was 0.97. 97% chance. Excellent. 97% chance that the kid got at least 2 makes. Okay? There you go. You've learned everything. Now, the quiz that you're about to take in class, the Schoology quiz, it covers everything. Not so much of the binomial, but more of this stuff. What's the difference between that and that? On one of them, the order matters, and one of them, the order doesn't. Can you tell me which one the order matters on? Say it if you know it. P. The order patters. I tried to give you a way to remember that with a P. Mildly annoying, but the order matters. This goes with P, so order patters. Okay. So if I say it's a race, does order matter in a race? Yeah. If I say it's a committee of 3 people that are all going to work together on this thing, committees, there's no order. If I say pizza, we're going to just put on these 3 toppings. Order doesn't matter. It's usually if there's some sort of a difference between the positions. Like there's a good spot and a bad spot. Well, then that's a P, if there's differences in the spots. Would you agree on the bus there is some differences of positions? There's good spots to sit on the bus, and then there's not as good spots to sit on the bus. I think a lot of you probably would just more care who you have to sit by. That'd probably be the biggest thing on the bus. But there are, especially like in a theater, there's for sure good spots and bad spots. So then the order matters. Because like a theater, they charge way more for up front than they do for in the back. Okay, so if it's a theater type question, it probably is a P. Order matters, P. All right. Well then, without further ado, open up your Schoology quiz. And actually, I'm going to pause for a second.